So this is a 10 week, week 10, chapter 10 sampling. In this chapter, this is the extension from the previous chapter where we covered descriptive statistics mainly. This chapter, the focus should be on inference statistics, which means when you are given some information about a sample of data, then you should be able to make an inference based on that sample. So more specifically, one of the takeaway of this chapter should be understanding that always large numbers of samples will get closer to population mean. And there are some functions that you are going to use. And these two videos explains just basics of sampling. One of the things that perhaps that video doesn't cover is about standard error. And one thing that we need to understand is why do we need to care about calculating standard error and calculating quantiles? It's because you want to make an inference based on the sample data. For example, when you are given mystery sample, let's talk about it using R. So in previous lab, you all were requested to write a function to read a URL and then as a result create a the data frame. So let's run that and then let's create a data frame. So we have df states created, which is 51 observations, 51 states basically, and 5 variables. That's our data frame, and the mean population of 2010 data is let's see, 66 million is the mean population of US states. And so one thing that you can do is to create sample means, and as the other video will cover, you can create sample means by sampling like 5 size. In the book it says 5. You can do either 5 or 50, but 50 is close to the population, but there's reason that I'm doing drawing 50. Okay, let's go with 5. So, and then let's double check how many sample means did you create. You have created 10,000, which you have written here. And the mean of this sample mean is 6 million, which is what is the mean of the data? df state. Which is very close to the population mean. Okay, so when you create a lot of samples and then create the mean, then it's close to the population mean, and you can create descriptive statistics of this new sample means by using summary function, minimum, maximum, and median and mean, and first quartile, third quartile. You can just only display this information by using quartile. And if you use a quartile function, the default is 0%, 25, 50, 75, 100%. And you can manipulate like what percentile you want to show by using these attributes. And you can create 2.5 percentile, which is 2 million, between 2 million and 12 million. So you can create this quantile. And then, so why do you create quantile? You want to compare the mean of new sample, whether or not this new sample mean is between this quantile range, to make an inference whether or not this new mean is created based on a sample from the population or not. So for example, there's a new sample, and your question is, okay, I got this mystery sample, and the question is this from the state population? Can it reflect state population or not? You can check if it does or not. So the mean of mystery sample is 800,000, which is very small compared to this quantile. It's smaller than 2.5%. So just to give you some explanation of a quantile, just this is an abstract level how you think when you are given that kind of information. So the quantile is basically what it does is if you draw multiple samples, many samples based on population, the mean will just keep creating the mean, and then it will become like this. Normal distribution is what the distribution is going to be. And the quartile that you just saw, 25 percentile and 97.5 percentile, what it shows is if your new sample mean is in this area between 2.5 and 97.5, and you can tell that it's highly likely this sample is from this population. But if the mean that you're given, new sample mean, is below this level, either here or if it's there, then you can say it's highly likely that this sample is from somewhere else. It's not the population sample. That's the inference that you can make based on the information that you get from the quantile function and then standard error that I'm going to explain. That's the use out of it to make inference. So you're given this data set, and the quantile, quantile value when you create a lot of sample means based on the 2010 population data. This will give you the range, and the new sample mean is below that level. That means it's highly likely that this new sample is not from the state's population. So that's one thing you can know. And you can make the inference using standard error, calculating standard error. That's what's explained in textbook 107 through 108. So first of all, to calculate standard error of the mean, you have to know standard deviation, and then n, how many samples you draw. In this sample means, when you draw it, you sampled 5, so that's why it becomes square root 5 here. And then standard deviation of of the 2010 population is divided by square root 5. So that's a standard error. The standard error is 3 million. And then based on that, you can calculate a cut point. So cut point is a mean of the value plus minus 2 standard deviation. So that's how you calculate it. So the cut point lower bound is minus 52,000 and the upper bound is 12 million. So based on this, it's this new mystery sample seems to be it's in that range. So if you use a standard error, it could be said that it seems like this mystery sample could be in this range. That's a little bit odd, but since we have used a very small size of samples, that's I think what we're seeing. So just to demonstrate you the importance of having more sample sizes, let's increase this sample size like 50 each time and then create 10,000 of them. So then we will see the standard error will go down because we increase the sample size. Standard error, the error will go down, right? And so we create sample means again and create sample summary of it, and let's create standard error and then cut points again using the 50 is our sample size now. So now standard error is extremely smaller than that, right? And then cut point, now instead of minus something, cut point is 4 million lower bound, and then upper bound cut point is about 8 million. So between 4 million and 8 million will be something, the sample mean that is likely to be drawn from this US population. That's what it says. And the mysterious sample mean was 800,000, which is smaller than the lower bound. And as I said before, the boundary is like this normal distribution, and the 800,000, this mean is out of this area, so out of this lower range. So you can say that it's likely that this mysterious sample is not from the US state population data. That's what you can say. Okay, hopefully this kind of makes sense about standard error. And for this week, you have one lab. Watch this video to understand sample and sampling. That has a good introduction about it. And then do this sampling lab. Okay, this is the end of week 10 sampling presentation.